So we'll just start with this and then we'll switch over to that.
Okay. So we are car tracking with encryption. Our motivation was to create automatic car parking, like for the spots and tracking, so that we can have a greater throughput on the on parking. Our target problem is finding a spot. So finding a spot today is just such bad efficiency, and you just go around and circle for hours, and where there has to be a better way. So that's our reason why we came up with this solution. Our project at a glance, so we have the parking lot sensors, the base station, the back end, and then the front end web development. And I'm going to hand it off to you.
So for the parking lot sensor, as last couple of presentation, I said that we were using the photodiode, which is built in on the TLSP board. So we use that photodiode to detect the light actually, and we're using that to actually tell whether the parking lot is occupied or it is available. And so we are reading it from the photodiode, and we're encrypting it using the AES-128 encryption standard. It uses a 16-byte encryption key. So it encrypts the light value that is read from the sensor, and it is wirelessly transmitting to the base station. So for the demo, we have three transmitters, the parking lot sensors, to send the parking lot indicator value, whether the car is parked or not. And so this is just a module interface. As the Dynamis it's a pretty modular operating system, and so certain modules that we use. The main module is for boot up. We have used the AMS sender and active message for generating and transmitting the packet, and another module, the Hamamatsu 108 for reading the sensor values, and AES encryption. This is another standard that we borrow from the different library to encrypt the message at the transmitter end. And for the brief about base station just receives the photodiode value, which is transmitted in encrypted form by the transmitter, and it decrypt the value and send it over to the backend program, which is on a computer over the serial port. And the modular interface is quite similar to the transmitter. So we are using the same components that we use in the transmitter, but at the AES end, we are using the 16-byte encryption key to decrypt the message that we receive from the transmitter. And
so the backend is written actually in C# on top of .NET 4.5, and so it has like three basic tasks. It reads the serial data from the base station. Then it updates its internal state, so based on sensor readings, and so after it generates a web page with JSON object, which is consumed by the front end. So it's like pretty.
Coming to the front end part, like we thought that we'll be implementing it in React, but later after doing quite research on React, we found out that it's very heavy library for a single page application, which is renders a small JSON file. The size of the React is only 0.5 MB. So we have stick to jQuery, Bootstrap, HTML and JS to design the front end. So the front end interacts with the backend, fetches the data from the backend, and displays the parking lots which are available and which are not available on the interface. And
So the demo. So this is our parking lot, and we have these three cars. And we'll skip the web page up. So this is our parking lot, this is the website, and the website reacts to the person who's parking. So say the first person comes along.
Okay. So we're gonna start with the backend application. So as you can see, it receives the data from the sensors. You can see the encrypted packets, and after it, the decrypted packets as well. Yeah. So now it should work.
So first car comes along, parks.
Yeah, it had the front end had like 5 seconds delay.
Yeah.
Right?
Maybe because the projector light is just too bright.
We just press it, yeah.
Turn off the projector light.
Yeah.
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 Okay. So then the second car comes, it parks right here, and you see how on the web page it'll update and show that the spots are taken. And now if the third car comes and it parks right here, then it'll take up that spot, and then you can see how it reacts to people parking in an actual parking lot.
So when the cars goes out,
And then when the cars leave, you see how it'll start. It'll start reacting and put it back.
yeah. So this is basically it.
Yeah, this is basically a model, and then we're gonna finish with the last couple slides. So, basically to conclude, we got the car tracking to work with encryption, and we were able to handle multiple boards. So I think we successfully showed that this is possible, and we could continue to add more boards. So the future works would be support more boards, have more base stations, integrate with the boards into an actual parking lot. So there's actually, you have to like be able to worry about the casing and stuff like that. So how they'd actually be placed in the ground. And then it could actually be integrated within a car. So if a car actually just reacts, loads the webpage of that building's parking lot, they could be able to find open spots easily. Any questions?
Any questions? First case? So that's all for today, and keep your working sheet in a secure place, and stay here on Thursday and next Tuesday. And on next Tuesday, make sure your demo can